the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Imagine a world without calculus. We couldn't determine the rate at which a volume is changing. An angle is changing. Or temperature is changing. If an ice cube is melting and the volume is decreasing at a constant rate of 3 cubic centimeters per minute, how fast is the height decreasing when the cube starts at 6 centimeters tall?
We can find that using derivatives. First, we take the derivative of the volume, which would give us 3s squared, ds over dt. Then we can go ahead and plug in what we know. We know that dv dt equals 3, and that 3s equals 6. And that gives us 1 over 36 equals ds dt. So the height of an ice cube is decreasing at the rate of 1 over 36 centimeters per minute.
We can also use calculus to work with volume. If a balloon is being filled with water at the rate of 7 cubic centimeters per second, what is the rate of change of the radius at the instant that the volume of the balloon equals 36 pi?
If we know that the volume of a sphere is 4/3 pi r cubed, we can determine the radius of the water balloon when the volume is 36 pi by setting these equations equal to each other. Using simple algebra, we can find that the radius of the balloon when the volume is 36 pi equals 3 centimeters. If we take the derivative of the volume, we get dv dt equals 4 pi r squared dr dt. Now we plug in what we know. dv dt is 7 centimeters cubed per second, and the radius is 3. Using simple algebra again, we can find that the rate at which the radius is changing when the volume is 36 pi is 0.062 centimeters per second. Oh!
If I am being pulled at a rate of 140 feet per minute and Kelsey is sitting 15 feet away from me, at what rate is the angle of inclination of Kelsey's line of sight increasing when I am 15 feet above the ground? Oh, God! Using trigonometry, we can find that tan of theta equals h over 15 feet. H over 15 feet. Next, we take the derivative of that and get secant squared theta d theta over dt is equal to 1 over 15 feet dh over dt. Next we're going to solve for theta. Theta over dt is equal to 1 over 15 feet dh dt over secant squared theta. Next we're going to plug in some of what we know, like dh over dt equals 140. Is that in there? Okay. Feet per second over secant squared pi over 4. Next we're going to rearrange the equation a little bit to get cosine. So we're going to write 140 feet per second over 15 feet times cosine pi over 4 squared. Plug that into our calculator and we get 18.667 radians over seconds.
2, 3. You were hard.
If Kelsey's scooter is 32 feet north of Liz's scooter and is scooting due south at 16 feet per second, Liz's scooter is sailing due east at 12 feet per second, at what rate is the distance between them changing at the end of 1 minute? Is the distance increasing or decreasing?
He's really freaked out by you.
All right. Using Pythagorean theorem, a squared plus b squared equals c squared, we can write an equation to represent this problem. A will be represented by 32 minus x squared plus y squared equals z squared. Now, to find the rate at which the distance between Kelsey and Liz is changing, we will take the derivative of this equation. We will have 2 times 32 minus x times negative dx dt plus 2y dy dt equals 2z dz dt. Now we plug in what we know. After 1 minute, x is 16 feet. And it's changing at a rate of 16 feet per second. Y is 12 feet. And then it's changing at a rate of 12 feet per second. Using Pythagorean theorem earlier, we know that z equals 20 feet, changing at an unknown rate. After multiplying everything out, we find that negative 244 feet squared per second equals 40 feet dz dt. If we divide both sides by 40, we eventually find that the rate at which the distance between Kelsey and Liz is changing is negative 5.6 feet per second.
Is being filled with water at the rate of 7 cubic feet. Damn. If a balloon is being filled with water at the rate of 7 cubic centimeters per second, what is the rate of change of the radius? You can also use calculus to determine volume. If a balloon is being filled with water at the rate of 7 cubic centimeters per second, what is the rate of change?
Alright, this one is a whole
of the
two!
rate? We can also use calculus to work with volume. If the rate of a balloon being filled with water, cut.